Question 12 is one of those cases where you really just need to memorize a specific formula here. There's not a lot that you're going to be able to do without it. I'm going to do it the way that most people kind of intuitively approach the question, but there is a little bit of a trick that we should be using from the get-go to make the answer easier. So, odds are, though, that you're not going to see it. If you know the rule involves fractional exponents. And so your instinct is going to be to turn this fractional exponent into a radical first. And the rule is that we have two pieces to a fraction, so we're going to have two pieces to the exponent, I guess. And so what we kind of learn in school is that the top is the power and the bottom is the root. And if you have trouble remembering that, remember the roots of a tree are on the bottom of a tree, so the root is on the bottom of these fractional exponents. And so what that means is we very quickly can turn this into the fourth root of 9 to the third. That's what most people do right away. And I think that's kind of the right thing. Now, it doesn't necessarily get us the right answer here. There's clearly nothing that's just exactly like that. But through logic, we can get rid of a few answers without doing anything else. Right? I think B is the most obvious, right? That's the fourth root of regular old 9. So where did the 3 go, right? That's part of this that shouldn't have just disappeared. So we can get rid of B because I may not know what the fourth root of 9 to the third is, especially without a calculator, but I know it's going to be bigger than whatever choice B is. I also might be like, well, choice A seems kind of weird, right? I know it's going to be a fourth root, so that's kind of weird, where the 3 I know is not supposed to go there. The other piece of this, though, too, then, is the C and D are also not fourth roots. They're square roots. So that's kind of weird. Maybe to you those don't seem different, but to me there's a big difference. It's easier to go from a fourth root, which is an even number, to a square root. That to me makes logical sense. Whereas like the cube root is kind of its own world. And I know that they're probably trying to trick me with the 3 because it was in the exponent, now it's somehow appearing in the root. So I would also eliminate A. And now, if the best you've got here is a 50-50 shot, I mean, that's not so bad. That's okay. Most people, though, I don't know that you'd know where to go from here. If we wanted to, what we could do is we could remind ourselves that the fourth root of 9 cubed is really 3 9s. Now, what I learned is that if I have whatever the root is, I need to make groups that are of that number, right? So I want to make groups of numbers in 4s because I have a fourth root. And every time I make a group of 4 of the same number, I can pull that out of the fraction of the root, right? So that doesn't happen here, but like to give you an example that's completely unrelated, if I had something like the square root of 8, well, I know that 8 is 2 times 2 times 2, and because it's a square root, if I have a pair of something, I can pull it out. So I have a pair of 2's, and I have 1 2 that doesn't have a pair. So the pair comes out, and the other remainder 2 stays behind. So that's the general rule for simplifying a radical. Here, we don't have a fourth. We don't have, we have three 9s, but not 4. But we can break 9 down the same way we broke 8 down into smaller numbers. So each of those 9s is a 3 times a 3. And so now we're cooking here. Now we've got 4 3s that can come up with a 4 group, right? That's kind of what I'm trying to do. And then I've got 2 that get left behind. So what does that get me? Well, that gets me now 3 comes out, and there's 9 that's going to stay behind. Hopefully, you can also now see that this is going to be at least as big as the number 3, right? It's 3 times something. I'm having trouble understanding the something, but 3 times something. Whereas choice C is just radical 3. That's actually smaller than the number 3, right? It's the square root of 3. So kind of for similar reasons that we crossed off A and B, what we have, even though it's not an answer, it cannot possibly match with choice C no matter what we do to it because it's already bigger than that, which leaves us with D, which is the answer, but obviously we'd love to prove it. And the best way to have proved it is from the start. What we should have done is we should have manipulated 9 to the 3/4 from the start. Because look at all my answers. Generally with radicals, I want to break a number into its smallest components early. So 9 to the 3/4 was already a disaster. What I should have done is recognize that 9 is 3 squared. Right? These two things are equivalent. Right? I could rewrite 9 as 3 squared. I haven't done anything except change the way a number looks. I've not changed its value. 3 squared is still 9. And then I use another rule for exponents, which is that if I have an exponent raised to another exponent, I multiply these two exponents together. So in this case, that would get me 3, and this is 2 over 1 times 3 over 4, which is 6 over 4. But we know with fractions that we're always supposed to reduce them. So 6 over 4 is the same as 3 over 2. And now I can apply the rule that I applied at the beginning, the power root rule, and I can turn that into the square root. I'll put the 2 there even though we don't usually put it, but the square root of 3 to the 3rd. And so what I'm looking to do is I'm trying to make a pair of numbers, and the square root of 3 times 3 times 3. I've got a pair of 3's that can come out, and one leftover 3 that doesn't have a match, that stays in. And the reason I need a pair is I know it's a square root. So that root tells me how many things need to be in the group. Before, it was a 4th root, so I needed 4 of the same number. Now it's a square root, so I just need 2 of the same number, a pair. And so that leaves me with a 3 on the outside and a 3 that gets left behind on the inside. And there's choice D, just as written. It's tricky, but I want to stress that, through memorizing the rule, no matter what way we did it, we at least got closer, right? So this one rule, this power over root thing, it's really important. It may come up on your test, and there's no real way to get this without that. But if you do know it, even if you don't do it like the way that they kind of want you to, you still have a 50-50 chance. And I think you have probably a better than 50-50 chance if you really think about it. So that's what we want. We just want to inch our way closer to the answer. And sometimes if we do have to guess, at least we're not guessing blindly. We've got reasons, we've got proof, and we can increase our odds and get more points in the long run.